Can you hear me properly?
No, sir.
इको हो रहा है वॉइस में.
हाँ ठीक है, एक मिनट में चेक कर लेते हैं. I'll check. Is that okay now?
Yes, sir.
Yes, sir.
Not good, is it okay now?
Yes, sir.
Yes, sir.
Okay. मैं एक्सपेरिमेंट के बारे में पूछ रहा था. Are you is the lab being conducted properly?
Yes, sir.
Okay. You are satisfied, is it?
Yes, sir.
ठीक है. तो लास्ट टाइम हम क्या देख रहे थे? लास्ट टाइम we were seeing the linear dependence or oblique independence of vectors, है ना? So you have a set of vectors. You have a set of vectors like this: x1, x2, so on, up to xm. This is a set of m vectors. Each vector having n components. And in order to test these vectors for linear dependence, independence, what do? We actually define the linear combination through real scalars, something like this: alpha 1 x1 plus alpha 2 x2 plus so on, plus alpha m xm equal to 0. Isn't it? And if the only solution to this, if this implies that all alphas are 0, then this set of vectors is linearly independent. But if there is a non-zero solution to this alpha vector, any non-zero solution to this alpha, then we say that the set of vectors is linearly dependent, isn't it? Now, if you have a set of m vectors, each having m components, let us say, in that particular case, it's easy actually to check the system of set of vectors for linear dependence, independence. What do? We actually create a matrix whose columns or whose rows are actually these vectors, and then we obtain, because that matrix comes out to be a square matrix in that case, we can obtain its determinant and then say whether the set of vectors is dependent or independent. But the problem that we are seeing is that we have a set of vectors x1 up to xm, wherein each vector belongs to an n-dimensional space, where we have last time seen that defined it like this: we have m is less than or equal to n, isn't it? M is equal to n, that problem is easy to solve. But when m is strictly less than n, so how do we solve this problem? How do we check whether the set of vectors is dependent or independent? I'll show you a method for that. So last time मैंने थोड़ा सा इसमें start किया था. What we had done was we had multiplied both sides of this equation. I call this equation 1. Equation 1 by x1 transpose, pre-multiplied by x1 transpose. So what do I get? Alpha 1 x1 transpose x1 plus alpha 2 x1 transpose x2 plus so on, alpha m xm transpose xm is equal to 0. Can you tell me what will be this x1 transpose x1 dimension? What is the size of x1?
Last unit
N cross 1.
x1 transpose.
It will be n cross 1. And what is x1 transpose?
1 cross
1 cross n. And what is this product? What is x1 transpose into x1?
1 cross 1.
1 cross 1. So it comes out to be a scalar, isn't it?
सर वो लास्ट टर्म में x1 का ट्रांसपोज है.
ठीक है ठीक है ठीक है. यहाँ पे ये x1 है. ठीक है. So it's actually 1 cross 1. So each term actually comes out to be 1 cross 1 here, isn't it? So this becomes a scalar 0. This is a vector 0, wherein the size of this vector is 1 cross n. ये सभी vectors 1 cross n, n cross 1 है ना? ये n cross 1 है. ये भी n cross 1 है. ये भी आपका n cross 1 है. सही है? Is that okay? We have pre-multiplied both sides of this equation first by x1 transpose. And what we do after that is we continue multiplying this equation 1. पहले हमने इसको x1 transpose से multiply किया. Now we'll pre-multiply it on both sides by x2 transpose. Pre-multiply both sides of equation 1 by x2 transpose. What do we get? We get alpha 1 x2 transpose x1 plus alpha 2 x2 transpose x2 plus so on alpha m x2 transpose xm equal to 0. Is that okay? Are you following me?
Yes sir.
इसी तरीके से मैं कंटिन्यू कर रहा हूं. I will continue multiplying till and I continue getting the equations like if I call this equation, let me call this equation 1, जो मैंने 1 इसको नाम दिया, let me call this as equation A so that I can start calling these equations as 1, 2. So this will be actually equation A. I am multiplying by this x2 transpose x1 transpose. Okay. So continue this process, continue this multiplication process. Continue multiplying, pre-multiplying. Equation A by x2 transpose के बाद x3 transpose से करेंगे, x3 transpose के बाद x4 से so on till we reach xm transpose. So you'll get many equations, and the last equation that you'll get is alpha 1 xm transpose x1 plus alpha 2 xm transpose x2 plus so on alpha m xm transpose xn equal to 0. The equation number क्या होगा? This will be equation number m, isn't it? So I'll write these m equations in matrix form. What do we get? Yes, help me. So we will have x1 transpose x1 x1 transpose x2 plus this one x1 transpose xm then x2 transpose x1, x2 transpose x2, so on, x2 transpose xm, similarly like this, xm transpose x1, xm transpose x2, so on, xm transpose xm, like this, and this is alpha 1, alpha 2, so on, alpha m is equal to all 0, 0, 0, so on. Is that okay? These m equations I have written in matrix form. So you can see x1 transpose x1 into alpha 1, because this is alpha 1 is a scalar, it can be anywhere. So x1 transpose x1 into alpha 1 plus x1 transpose x2 into alpha 2 plus so on, x1 transpose xm into alpha m. That was the first equation. This one, isn't it? ये आपका सेकेंड इक्वेशन हो गया. इसी तरह आपकी m इक्वेशंस हमने मैट्रिक्स फॉर्म में लिखी. Is it clear up till now?
Yes, sir.
Okay. Now, does this x1 transpose x1 remind you of something? If you have a vector, let's say 1, 2, 1, 3. Let me call it x1. You have learned about the dot product of vectors, isn't it? How do you obtain the dot product of vectors? For example, you have to obtain the dot product of x1 with itself. x1 dot x1. That's actually defined as x1 transpose into x1. That means you do something like this. 1, 2, 1, 3 multiplied by 1, 2, 1, and 3. Scalar product. So this is actually 1 into 1 is 1, plus 2 into 2 is 4, 4 plus 1 is 5, 5 plus 1 is 6, 6 plus 9 is 15. It will come out with 15. So this x1 transpose x1, this is actually the dot product of x1 with itself, x1 with x1. This is by definition how we define the dot product of two vectors. Similarly, x1 transpose x2, this is actually the dot product of x1 with x2. This is just for your information I am telling you, this product, each term here represents the dot product of vectors. Otherwise, it has got no significance as far as the problem that we are solving. Okay. So, now what is the dimension of this vector? This matrix? Yes. M cross M, है ना? And this is an M cross 1 vector of alphas. And this is also M cross 1. Now this matrix, I name it as G matrix, capital G. And this vector of alphas, I call it a big alpha. And this is a zero vector, M cross 1 zero vector. So this set of equations can be written as G, a big alpha, is equal to 0. Isn't it? Are you getting me?
Yes, sir. Yes, sir.
This is a set of M simultaneous equations. Now, you know, this is an equation of this form. Ax equal to 0. Isn't it? Now, the solution of this equation will depend upon the rank of this matrix A. If A is a full rank matrix, That means if determinant of A is equal to 0, sorry, if determinant of A is non-zero, A is a full rank matrix. In that particular case, the only solution of this equation is alpha is equal to 0. Isn't it?
Yes, sir.
Okay. So the solution of this set of equations will depend upon the rank of this big G matrix. If G is a full rank matrix, that is determinant of G is not equal to 0, then this set of equations will have a unique solution and the solution will be, and that unique solution will be this alpha vector equal to 0. That means all alphas equal to 0, which actually implies alpha 1 equal to alpha 2 equal to alpha 3 is equal to so on is equal to alpha m is equal to 0, implying linear independence of the given set of vectors. Do you get me?
Yes, sir.
So the problem of obtaining the linear dependence or linear checking whether the set of vectors is dependent or independent, now that problem has been reduced to obtaining the rank of this particular matrix, G matrix, whose composition is something like this, which I have already discussed. The composition of that matrix is something like this. On the other hand, if G is a rank deficient matrix, okay, that means it's not a full rank matrix. That is, determinant of G is equal to 0. The set of equations will have many solutions. Will have many non-zero solutions. Are you getting me? That is, this vector alpha not equal to 0, implying linear dependence of vectors. Are you getting me? Yes, anybody may respond.
Yes, sir. Yes, sir.
So this matrix G is known as Gramian matrix. ये सारा डिस्कशन मुझे ये ग्रामियन पॉइंट इंट्रोड्यूस करने के लिए करना पड़ा. Is that okay? This matrix G is known as the Gramian matrix. So if you have been given a set of vectors, set of m vectors, each of which lie in an n-dimensional space where m is less than n, and you are asked to check the set of vectors for dependence or oblique independence. So what do? You frame this Gramian matrix. And the Gramian matrix, I have shown you how it looks like. And then obtain its rank. If it is a full rank matrix, then the given set of vectors is linearly independent. If it is a rank deficient matrix, then the given set of vectors is linearly dependent. Is that okay?
Yes, sir.
This matrix G is known as the Gramian matrix. तो जो हमारा प्रॉब्लम था कि हमने देखा था कि अगर m n के बराबर है, उस केस में प्रॉब्लम सिंपल है. हमने एक मैट्रिक्स बनाया, उसका डिटरमिनेंट चेक किया, अगर वो जीरो है तो आपका सेट ऑफ वेक्टर्स डिपेंडेंट है, अगर नॉन जीरो है तो इंडिपेंडेंट है. तो हमारा when we had the difference between m and n, that means m was less than n, in that particular case we couldn't use that particular technique in order to obtain the dependence independence of vectors. So now we have obtained one more method wherein the same thing can be used again. Now we have a matrix which is a different matrix known as a Gramian matrix. Gramian matrix, you have to just first of all formulate this matrix and then check its rank. It's a square matrix. You check its rank, and if it comes out to be a full rank matrix, then the given set of vectors is independent. If it is a rank deficient matrix, then the given set of vectors is linearly dependent. Is that okay?
Yes, sir.
तो मान लीजिए आपके पास चार वेक्टर्स हैं. लेट्स से यू हैव गॉट सम वेक्टर्स लाइक दिस. यू हैव गॉट x1 equal to let's say you have got 1, 2, 3 and 4, and x2 is 2, -1, 3 and 5, and x3 is 3, 4, 6 and 7. Okay, so how many vectors have I given you? 3.
3.
And each vector belongs to which space? Each vector has how many components?
4.
4 components. So each vector belongs to a 4-dimensional space. Now I have to see whether this set of vectors is dependent or independent. So what do I do? What is the procedure now? I make a Gramian matrix. Okay. I define a Gramian matrix. And what is the composition of Gramian matrix? It's like this. x1 transpose x1, isn't it? x1 transpose x2 and x1 transpose x3. Then x2 transpose x1, x2 transpose x2, x2 transpose x3, x3 transpose x1, x3 transpose x2, and x3 transpose x3. Is that okay? This is how we have defined the Gramian matrix. Have I written it correctly?
Yes, sir.
तो अब मुझे ये 3x3 मैट्रिक्स की रैंक देखनी है. मुझे उसी से मतलब मुझे पता चलेगा कि गिवन सेट ऑफ वेक्टर्स डिपेंडेंट है या इंडिपेंडेंट है. पहले हम x1 ट्रांसपोज x1 ऑब्टेन करेंगे. x1 transpose x1. So that's like this. 1, 2, 3 and 4. Then 1, 2, 3 and 4. How much is this? This is 1 plus 4 plus 9 plus 16. That's 25 and 4, 29. That's 30. Then x1 transpose x2. That's actually 1, 2, 3, 4. And what's x2? 2 minus 1, 3 and 5. So this is 2 minus 2 plus 9 plus 20. This comes out to be 29. So yeah.
Yes, sir.
Now x1, go on calculating it. Tell me what is x1 and just tell me what will be G matrix. Give me this G matrix. Roll number 46.
Yes, sir.
What's the name?
Yes, sir. Hello.
What's the name?
सर सर सर
क्या नाम है आपका?
सर मनीष मनीष
मनीष, बताओ बताओ ये जी क्या आ रहा है?
सर प्रोड्यूसर
करो जल्दी से। सारियान गुप्ता।
Yes, sir.
हाँ जी बताओ।
Yes, sir. Solving.
जी मैट्रिक्स बताओ मुझे पहले क्या आ रहा है जल्दी से।
Hello, sir. Hello.
यस, आर यू डन?
Yes, sir. It
बताओ।
will be, sir. First row will be 30, 29, and 57.
29 and 57.
Second row will be 29, 39, and 55.
Okay.
And third row is 57, 55, and 110.
कोई चेक करो।
सर
इज ओके।
यस सर, यही आ
यस
रहा है।
सर
ये यार अब इसकी रैंक देखो। इसका डिटर्मिनेंट देखो क्या आ रहा है। रैंक देख, एब्सोल्यूट रैंक देखने का सिंपल तरीका है कि आप डिटर्मिनेंट देखो। अगर आपको प्रॉब्लम बस इतनी है कि आपको देखना है कि रैंक ये फुल रैंक है या नहीं है, तो उसके लिए डिटर्मिनेंट ऑब्टेन करके आप बता सकते हो। डोंट यू हैव कैलकुलेटर्स? कैलकुलेटर पे तो ये 1 सेकंड में हो जाएगा। सो गए क्या सब लोग?
सर 559 आ रहा है।
Sir, 559.
डिटर्मिनेंट ऑफ जी कितना आ रहा है?
559.
559. व्हाट डज दैट मीन?
It is not a full rank matrix.
जी इज
Full rank matrix.
ए फुल रैंक मैट्रिक्स है ना? व्हाट डज दैट इंप्लाई?
So sorry, sir. Full rank.
यस।
Sir, vectors are linearly
Linearly
independent.
dependent,
So
sir.
x1, x2, and x3 are linearly what?
Dependent.
Linearly independent. है ना? तो समझ में आया कैसे देखते हैं डिपेंडेंस इंडिपेंडेंस वेक्टर्स की? Is it an easy way of obtaining the dependence independence?
No, sir.
It's not an easy way.
I don't think so.
So what do you think is the easy way? Who is this? Who is this student? इसमें क्या डिफिकल्टी लगी आपको?
सर इसमें हर एक का प्रोडक्ट निकालना पड़ेगा बिना कैलकुलेटर के हो नहीं सकता।
What other method do you have for doing this? तो प्रोडक्ट
सर
निकालने
मैं सोच रहा था कि हम एक लैम्डा आर्बिट्ररली लैम्डा मान लेते हैं सर, समथिंग x इक्वल्स टू लैम्डा, फिर उसके लिए सॉल्व कर लेते हैं।
क्या करोगे
सर? लेकिन वो दो तीन वेक्टर के लिए हो सकता है, दो तीन मतलब डायमेंशन के लिए हो सकता है सर। सॉरी सर, मतलब हमारे कहने का मतलब था कि सर हम सपोज कर लेते कि ये हमारा जैसे होता है ना लिनियरली इंडिपेंडेंट का कॉन्सेप्ट में हम x इक्वल्स टू लैम्डा ले लेते हैं सर, फिर उसको हम लैम्डा को सर पुट करके एक रिलेशन बना लेते हैं x1 x2 x3 में,
हाँ
फिर वहां से हम लोग देख लेते हैं
वो
सर।
भी उसमें भी मैथमेटिकल व्हाट यू कॉल कॉम्प्लिकेसी है और मैथमेटिकल कॉम्प्लिकेसी उसमें बढ़ेगी जितना जितना नंबर ऑफ इक्वेशंस बढ़ेंगी, है ना?
यस सर, वहीं सर।
तो ये वाले मेथड में डिफिकल्टी तो है नहीं कहीं पे। प्रोडक्ट करना है, डॉट प्रोडक्ट करना है, डॉट प्रोडक्ट इज वन ऑफ द इजीएस्ट ऑपरेशंस दैट यू कैन परफॉर्म ऑन वेक्टर्स, इजंट इट? Plus one more thing is there, you will always find that this Gramian matrix is a symmetrical matrix. And in effect, अगर ये 3x3 matrix है, आपको total entries इसमें कितनी actually obtain करनी है? कम ही करनी है obtain. All the entries you don't need to obtain. As you can see here also, it's a symmetrical matrix because dot product is commutative, isn't it? And this is a numerically beautiful way of actually obtaining whether the given set of vectors is dependent or independent. Is that okay?
Yes, sir.
अभी जो ग्रामियन मैट्रिक्स इंट्रोड्यूस करने का मेरा मकसद था वो भी पूरा नहीं हुआ, because we are still talking about vectors. We actually have to talk about vector functions, which we will do later on, because we are basically defining. ये ग्रामियन एक्चुअली आया कहाँ से था? हमें we were actually doing controllability tests, isn't it? Controllability test में मैंने आपको कहा कि we define something known as a controllability Gramian and then check its rank. I'll come back to that. I'll come back to that after some time. Now, let's say you have another set of vectors like this. Let's say you have got a set of vectors like 1, 2, 4, 3, 1, 6, 2, 1, 7, and 4, 1, 0. Enrollment number 53.
Yes, sir.
Now, tell me what about the dependence independence of these vectors. How will you check whether this set of vectors is dependent or independent?
सर इसका रैंक देखिए जी मैट्रिक्स का। सर ये सर इसे हो गया सर ये
सोच के बताओ।
सर ये 3 है और वो 4 सर
I'm giving you 4 vectors. Each vector has got 3 components. That means these 4 vectors belong to a 3-dimensional space, isn't it?
Yes, sir.
Now tell me how do you obtain whether this set of vectors is dependent or independent?
सर देखने से तो लगता है इंडिपेंडेंट होगा सर, क्योंकि 3 वेक्टर सर 3 डायमेंशनल स्पेस के वेक्टर।
फिर से बोलो
सर इंडिपेंडेंट, लीनियरली इंडिपेंडेंट।
लीनियरली इंडिपेंडेंट
सर क्योंकि ये
can you have a set of 4 linearly independent vectors in a 3-dimensional space?
Sorry sir, linearly dependent.
They'll be linearly dependent. You can never have 4 independent directions in a 3-dimensional space. So you don't need to check dependence independence through any method here. you should straight away say that they will
Yes,
be
sir.
linearly dependent. Is that clear?
Yes, sir.
इसी तरीके से अगर आपको सेट ऑफ वेक्टर्स दिए गए हैं, लेट्स से 1 4 1 5 2 1 6 2 and third vector is like this, and you are asked to obtain whether this set of vectors is dependent or independent. So what do you say about this?
So dependent है sir.
It will be dependent because whenever you have a zero vector in a set of vector, it will always
We
be
can
dependent.
express certain direct zero.
Isn't it?
Yes.
Linearly dependent. So I'll stop here and we'll talk about other things after your examinations. आपका पेपर कब है कंट्रोल का? Have you gone through the date sheet?
Excuse me, sir.
Yes.
Sir, will our syllabus for midterm be up to today's lecture?
पहले मेरे क्वेश्चन का जवाब तो दो. When is your control systems paper?
Sir, Wednesday, third paper.
Wednesday. So you should first answer my question and then ask your question. So it's on Wednesday, is it? So by Sunday we'll give you the mode of examination, how we will be actually conducting the examination, and the syllabus for the examination will be everything including what has been covered till today. Is that clear? अभी
Yes,
तक जो भी कवर हुआ वो पूरा एग्जाम में आएगा. Anybody having any doubt?